Reliability Solutions presents Key Tips, Techniques, Behaviors, Methodologies. Welcome to Chalk Talk. Does that sound or look familiar to you? How reliable are your belt drives? Historically, we find it is often hard to justify improvements to belt-driven equipment. Squealing, slipping belts are often ignored until they completely fail, causing a significant production or even a safety loss. There's a variety of products out there to hide the problem, and they often only make the problem worse. When arguments are made to do something about the problem, the discussion often centers on the phrase, well, belts are cheap, we'll just change them when they break. So how do we justify applying reliable manufacturing techniques to belt-driven equipment? It's really not that hard. We all know there are many causes of belt problems out there, including tension, pulley and sheave wear, overload, worn belts, contamination, overheating, all kinds of different problems. Nearly all of these end up causing the belts to slip. We know that properly adjusted V-belts slip between 2 and 5%. Anything more than 5% means energy is being wasted. We can use a strobe light or tachometer to measure the actual RPM of the driver and the actual RPM of the driven. And from that information, we can calculate how much slip is actually occurring. The slip is simply the difference between the theoretical RPM of the driven unit and the actual RPM of the driven unit, expressed as a percentage. Before we can calculate the belt slip, we need to know the size of the pulleys on our machine. So I'm going to go ahead and measure the pulleys on this machine. When I measure these pulleys, I see that the smaller pulley is 4 inches in diameter, and the larger of the two pulleys on the driven unit is 6 inches in diameter. Now I have those measurements, I can do a couple of quick calculations on the board. So back at my whiteboard, we determined that the RPM of the driver was 1765. The actual RPM of the driven was 999.5. From that, the first thing I can do is calculate the theoretical RPM. So that's going to be 1765 multiplied by 4 divided by 6. And that equals 1176. So to calculate the amount of slip I have, what I need to do is take the theoretical RPM, which is 1176. I need to subtract the actual RPM, which was 999.5. And that equals 176.5. What I then do is divide that by the theoretical speed, 1176, and that will come to 15%. And 15% slip is, of course, a lot more slip than we would expect on a motor, indicating that the tension needs to be adjusted. Now, if we have a motor putting out 100 horsepower and we have 15% slip on the drive, how many horsepower are we losing? Yes, you guessed it, 15. We have clients that have documented tens and hundreds of thousands of dollars in savings due to slip. Here are a couple of examples on the screen right now. So there you have it. Eliminating belt slip can literally add tens or hundreds of thousands of dollars to your bottom line. When are you going to start? Reliable manufacturing is effective organizations, precision maintenance, process excellence, and asset condition assessment. To get your reliable manufacturing roadmap, contact us now